Here's the question. We have to solve. So this is the end. This chapter. What's chapter 6 been all about? Square roots, right? Chapter 6 has been all the rules for radicals, they call them, square roots. Now, last thing is, how do you handle a square root in an equation? You got an equal sign here now. What do you do when you have an equal sign and you got a square root? Yeah, you got to get rid of the root. What's going to get rid of a root? 2 power. Do you know those are opposites? Let me prove it to you over on the side for a minute. If I have root 7 and I put a 2 power on it, what is a 2 power on anything? I'll put parenthesis 2 power. Doesn't that mean 2 of them? Of course it does. And 2 7s in? See how it gets rid of the root?
You just 2 power both sides?
Exactly. Does that make sense? See how that gets rid of the root? See how that's the opposite? It's like an acid and a base, or a poison and the antidote. It eliminates it, doesn't it? Does everybody see that? So you just come in here and you go parentheses, 2 power. And you can just cancel it. I'm not going to, write it. Just cancel. Let's just save a step. Let's just cancel it out. Do you see that's what it did here? See how it really effectively just got rid of the root, didn't it? Am I going too quick? Does everybody see what I'm saying there? Right? When you put the 2 on the root. See the logic there? It means 2 of them, doesn't it? And 2 in, 1 out. So it brings it out, doesn't it? So when you put a 2 on a root, they cancel, and it brings out whatever was in. So in this case, 4x minus 9 comes out. Now what's the other side? Well, 1 times 1 squared, 1 times 1 is just 1. And we got rid of the root. That's how you get rid of the root. You 2 power both sides. Because a 2 makes 2 in, so 1 out. And now you know how to solve for x from here, right? Just add the 9. 4x is 10. Last step. Divide by 4. X is... And you got to reduce all fractions, huh? So divide top and bottom by 2 there. Be 5/2. We're done. Is that good? Is it making sense? All right, so I'll write that game plan out. Let's go to number 2, and I'll write out the whole plan. So number 2 says square root of y plus 3 minus 3 equals 4. So a root with an equals. Here's the plan. Step 1. Get the root alone and go parenthesis 2, parenthesis 2. There's the plan. Can you try it on this one? So here we are in question number 2. So first step is to get the root alone. What do I mean alone? Well, here's the equal sign. That's like the wall, left side, right side. Is the root all by his lonesome, or has he got somebody with him? Yeah, so what do you got to do? Add the 3 first. You got to get that root alone before you do the parenthesis step. You can't do the parenthesis step right now. First, still, step 1, get it alone. We good to there? See how the root's alone now? He's the whole left side now. Right? Now do the parenthesis 2 power, both sides. First get it alone, then 2 power both sides. So now we 2 power, parenthesis 2 power, parenthesis 2 power. What happens on the left side? The root just cancels the 2 power, huh? Right? Because 2 in, 1 out. Out comes the y plus 3, gets rid of the root. Other side, 7 squared. 7 times 7, 49, huh? What do you got to do to finish getting y alone? Subtract 3. So y equals 40, was that 6? Y equals 46.
You have to check the answer.
Yeah, I'm going to wait till we really need to. Yeah, this one checks. Yeah, you're totally right. Yeah, I'm going to hold off till they're ready, but yeah. Is that good? Our answer is good. Questions I can answer? Look. You 3 power both sides. See how easy math is? Not always, huh? I know it can be a mess. I'm just giving a false look to it when I say that. All right, yeah. But this part's easy anyway. Yeah, if you have a 3 in the hook, you 3 power both sides. Right? Now, let's look back for a minute. See, what was in the hook here? Yeah, nothing, which means invisible 2. That's why we 2 powered both sides. Because there really was an invisible 2 in the hook. So if you have a 3 in the hook, you're going to 3 power both sides. So remember, there's parentheses, though. So you're going to go parenthesis, 3 power, parenthesis, 3 power. That good? And then that cancels the root. Why? Why does it? Well, because that'll be 3 of those, won't it? 3 in, 1 out. Because that's the deal when you have a 3 in the hook. Right? 3x is in, 1x out. What's the other side? Whatever your calculator says. It's -7 times -7. What's the side? Is it going to be positive or negative? 3 negatives? Negative, is it 243? 343. There it is. We good?
So like the number in the hook determines how many.
The what's that?
So like the other ones we did, the number in the hook determines
What the power is. That's right. Whatever's in the hook, we raise it then to that exact same number. Exactly right. Got a 2 in the hook, you 2 power. You got a 3 in the hook, you 3 power. Exactly. All right. How about number 4? Third root of x plus 2 is 4. Yeah, try it out. Same kind of thing, right? What are you gonna do to both sides? 3 power it. Exactly. So 3 power both sides. And it cancels. The other side, 4 times 4 times 4, use your calculator. 64. There. And now, so we got rid of the root. See how we're always getting rid of the root by powering? Now what do we do to finish getting x alone? Just subtract 2 there. X is 62. How are we doing? Just better than that last messy stuff? The other stuff was getting messy. This stuff will get messy at the end, too. They always start nice, don't they? And then they just start throwing in everything with the kitchen sink. Steps. I gave you the 2 steps. So for the root steps, step 1, root with an equal sign, I should say. So it was root with an equal sign. So step 1, what do you do first? Get the root alone. So what are you going to do? This root saying, I won't be alone. What do you do first? Subtract the 3, yeah. Is that good? Get the root alone. First. So before you do the parentheses and the power, get the root alone. Then what do you do from here? Now we're going to put the parentheses and the power on both sides. What power? Third, whatever's in the hook, huh? They cancel. They're opposites. So it just comes out, and 4 times 4 times 4 is the same thing it was a minute ago. 64, huh? And then, how do you finish getting x alone? Subtract the 4. 2x equals 60. Last step. Divide by 2. X is 30. X is 30. Are we good? Questions on that one? All right. Hey, what is it we're doing here? Do you realize we're finding the answer that makes the equation true? If you went back here to the beginning and you put 30, that's our answer, right? In for x, we're saying x was 30. You would make that equation true. Do you see it? Do you see it up there? I kind of get this out of the way, right? You would have the cube root. What's 2 times 30? 60 plus 4 is 64. And what's the cube root of 64? Yeah, do you know what times itself 3 times is 64? You check it on your calculator, it's 4. 4 times 4 times 4. So this is 4 plus 3. Yeah, that's 7. It's true. That 30 is making the equation true. That's what we're finding. The number that makes the equation true. That's what it means to solve an equation. Find the number that makes it true. And we did. It's kind of amazing how it pins down that number for us by using logical steps. Okay. So, what are we supposed to do on this one? Yeah, parentheses, 2 power, parenthesis, 2 power. Okay, now it's going to get a little messy. It's because of that plus and minus. Like always, pluses and minuses make everything harder. Okay, so now we're going to have an easy side and a hard side on this one. The easy side is going to be the side where the root is, actually. That's the easy side. Why? Because these just cancel. They just cancel. Nothing fancy going on there. Remember, they're the poison and the antidote. They just eliminate each other. Done on that side. But on the other side, you're going to have to actually write 2x minus 9s and FOIL it all out. Now, hold on a minute. Hold on. Why? Why did I write 2x minus 9s on the left side? I didn't write 2x minus 7s on the right side. I had a 2. Why didn't I? Because the root canceled out the poison. There's no more poison on the right side. Are you with me? Everybody see that difference? On the side with the root, see the 2 is crossed off. See? Gonzo. And the root as well. That's the difference. The side that has the root and the 2, they eliminate each other, so there's no more 2. We're not going to do 2 of anything. But on the left side, you still have the 2. Nothing eliminates it. There's no root to eliminate the 2 on the left side. So you got to write 2 of them, and you got to FOIL. That makes that the harder side. Because it's the 2's not canceled, and we got to do the whole FOIL thing. See the difference? That'll happen pretty much every problem from now on. There'll be an easy side where the root just cancels the 2. And a hard side where you got to do the 2. Okay, let's do the 2. You know how to do it. Just FOIL, right? First to both, second to both. X squared minus 9x. Boom, boom. Minus 9x plus 81 is x minus 7. Okay, what happens next? Let's gather like terms here. Minus 9x minus 9 is minus 18x. Is that good to there? What in the world are we supposed to do now? Yeah, good memory. Remember when you see x squared, there's like a whole new issue. X squared has shown up on the scene. What do you do when you have x squared with an equal sign? Step 1. So this is a whole new game plan. We've done it before, though, so it's not really new, but it's new today. We haven't done it yet today. When you have x squared, remember you got to get a 0. And then step 2 is factor, like with the parentheses. And step 3, each part gets its own 0, and you solve. Remember the x squared game plan? So that's going to start happening in this section now. So you got to keep both game plans clear. The square root game plan and the x squared game plan, because now all of a sudden x squared's shown up. So what am I going to do when there's x squared? Get a 0. Where do you get 0? On the opposite side from x squared. So that means I got to make this side become 0, don't I? X squared's on the left. You got to make the other side become 0. So how do I make this side become 0? Just do the opposite, huh? Is that good? Bang, bang, gone. Like that. So we get x squared minus 19x plus 88. Let me slow down there for a minute so everybody see what happened. Everybody see what happened there. Whenever x squared shows up, so that's the thing I said to you. They wake you up in the middle of the night, right? I say x squared with an equal sign. Get a 0. You want to just pop up. Get a 0. It's going to come up. I like I said all throughout this course. Remember I said it'll just keep coming up. Keep coming up. So whenever you see x squared, you think, make the other side 0. So I did opposite of x, negative x. Opposite of negative 7, positive. Do it to both sides. Cancel 0. Other side, minus 18, minus 1 is minus 19. 81 and 7 is 88. Now I've got to factor that, like the 2 parentheses. So I got my 0. Now factor 2 parentheses. So x is in the front. What are 2 numbers that multiply? What times what's 88? 8 times 11, huh? And sign in the middle goes on the bigger. They're both negative, actually, huh? Negative 8, negative 11 make negative 19, don't they? In the middle. And 2 negatives multiply to be positive. That's perfect. And then so that's step 2, factor. Step 3, they each get their own 0, don't they? Right? Why is that? Because if 2 things times to be 0, either one could be 0 to make that happen. Bump the 8 over, bump the 11 over. X is 8, X is 11. Right? It changes to positive, right? When those negative numbers jump to the other side, negative 8 jumps over, becomes positive 8. Negative 11 jumps over, becomes positive 11. So the 2 answers are 8 and 11. How do you know? Nice. You're right. One of these is an imposter. One of these is masquerading as a real answer, but he's false. Yeah, I wanted to not bomb you with too much information all at once, but this is what Wendy meant. And Wendy knew as soon as we started this section that when you have square roots, you have to check your answers. This method we're using has the ability to give us false answers. I remember working with my own daughter years ago, my oldest girl who's away at college now, on these, and saying to her, hey, honey, you have to check these. I was doing some math with her at the home, and she said, oh, no, Dad, I never check. They always say check. I don't bother to check any of these problems, you know. And I said, oh, no, honey. It's not, I know what you mean. I know that, you know, math books always want you to check everything, and who's got time for that? I know, and that's fine normally. I said, but these kinds, I want to make sure you understand what I'm saying here too. These kinds must be checked. This isn't just, hey, it's always a good idea to check. No. You'll actually have false answers. And you didn't do anything wrong. You did all the steps right. This method has the potential to give you false answers. It's the best method we got. But it can give you false answers. It's like if you have a good friend, but they're a liar. Then you probably shouldn't have a good friend who's a liar. You know, what would that mean? You always got to be checking your friend. You know, whenever it's comes in. I was at junior college. I was 3 years at Sierra Junior College up in Sacramento, California. Sacramento. Anyway, I played on the tennis team a couple of years there, and we all knew we had one guy on the tennis team. What was his name? Anyway, he was a cheater, and we all knew it. Kevin was his name. And anyway, we all, like, all the rest of us knew he would just cheat. And in tennis, what you do is you call your own lines. So you play a match. You know, we'd go to some other school, go to Yuba College or Sac City College, or you know, I was at Sierra Junior College, Rockland. Anyway, we'd travel on the bus. We get off. We play. Everybody lines up. You play your matches. You know, and invariably, most times, we'd all be all 6 courts. Everybody's, you know, the coaches are walking up and down, watching all the matches, and you know, about a half an hour in, we'd hear from Kevin's court somebody yelling out, "Hey, that ball was in. You know," and so they call for the coach. So if somebody's cheating, you call for the coaches, and they go and they watch that match for the rest of the match. And every time, you know, it'd be a half an hour in, and we'd hear yelling from Kevin's court. And my buddy and I would look at each other and go, "Kevin's cheating again," you know. We just knew it. He was just a cheater. That's what he did. And so anyway, so that's what this method is. It can give you false answers. So you have to check it. It's not just like you should because it's a good idea. You have to. One of these answers is actually false. Claudia's right. It's the 8. How do you know? Well, let me go to a fresh screen here. So what was it? X minus 9. What was the original question? Equals square root of... So just go back to the beginning and then check them one at a time. Let's check the 8. And then after I've done that, over here I'll check the other one. What was the other one? 11. So just check them one at a time. It's a little time consuming, unfortunately. So what do you do with the 8? You plug it in. It's got to make the thing true, right? That's what it's supposed to do if it's a real answer. So 8 minus 9 is the square root of 8 minus 7, is it? Well, this is negative 1. This is the square root of 1. What's the square root of 1? 1. No, that's not true. Negative 1 doesn't equal positive 1. No, that's a false answer. Let's check the other one. So for the other one, you're supposed to plug in 11. Remember, x can only be one number at a time. It's either 8 in both spots or 11 in both spots. So if it's 11, that would be what? 2 equals 11 minus 7, 4. Square root of 4. Yeah, that's true. See how the 11 works perfectly. He's the real answer. He's the real answer. So the only answer you type into Math Excel is 11. Or on the multiple choice test, just grab 11. That's the only one that's the answer. The 8 was an imposter. Does that mean? Now, don't get the idea that there's always one bad, one good. There often is. But they could both be good. They could both be bad, and it's no solution. So all kinds of varieties can happen. Both good, both bad, one bad. Anything can happen. Usually it is one good, one bad. We good? Questions on that one? Yeah, so let's write out the square root with an equals game plan. Step 1. Get the root alone. I'm going to add to this. I kind of dribble out the story as we go because I don't want to overwhelm you. It's okay to leave a number multiplied in the front. You know how I say you got to get the root alone? Really, I mean you got to get rid of things added and subtracted. Like always, adding, subtracting is the problem. So what I mean by that, why I'm bringing that up now, is because I am going to subtract 1, definitely. Need to get rid of that 1. This is x minus 1, isn't it? But I'm going to leave the 6. He's really not a problem. Why? Because he's just times, right? He's right next to the root, no symbol in the middle. I mean, times, doesn't it? That's 6 times. He's not in the hook. Everybody see what I'm saying? He's not a tiny little 6 in the hook. He's just a big old 6 multiplying the front of the root, isn't he? He's not a problem. Now, and in fact, it would be difficult to get rid of him. What if I did try to get rid of him? What would I have to do? I'd have to divide. And if I don't write this down, this is not what we're going to do. If you divided by 6 on one side, what would you have to do on the other? Same thing. And then look, then you'd have a fraction. We don't want to go there, right? That's why I'm saying, hey, if get rid of numbers added and subtracted. Yeah, they're a problem. But numbers that are times in the front of the root, they're fine. Just leave them. So when I said get the root alone, really the whole story is get rid of anything added or subtracted next to the root. Leave the other stuff. All right, so step 1's over. We got the root alone enough. Step 2, what are we going to do now? 2 power. Parenthesis 2 power, right? Parenthesis 2 power, parenthesis 2. So I'm going to go parenthesis, notice, around the whole left, including a 6 that's not in a root. And parenthesis around the right side. Now, what's going to happen? This 6, the 2 power is going to hit him. 6 squared is 36. And what's it going to do to the root? Cancel. What happens on the other side? 2 of those. Let me pause for a minute. That's easy to mess up on. Does everybody see what happened there? Let me squeeze this in with a little more room. See what happened. Basically, here's the way it rained last night, right? It's like these last rains before. So, well, don't they actually say April showers bring May flowers, right? Anyway, so it might rain still in April, but these are some of our last rains. So let me use the rain analogy here. So basically that 2 power is raining down on the 6 and the square root of x minus 1. If you go out in the rain, you don't have an umbrella, you're going to get wet. So that 6 is not protected by a root. He doesn't have an umbrella, so to speak, over him. So he gets squared. But the x minus 1 is shielded, isn't it? So it doesn't get, there's not 2 of them. But the x minus 1 on the right side, he does not have an umbrella, so there's 2 of them. So in other words, simply put, anything protected doesn't get rained on, doesn't get tubed. Anything without an umbrella gets repeated twice, doesn't it? Are you tracking with me? You seeing? Over here, this 6 does not have a protection, so he gets squared. The x minus 1 on the right side also does not have a root over it. It gets squared, 2 of them. But the x minus 1 in the middle, he's protected. He's got his umbrella. He doesn't get wet. He doesn't get squared. It's just 1 of him, not 2 of him. Everybody see that? The only way you don't get squared is if you got a shield over you, a root over you. That protects you. That's the antidote. Right? Are we good? So now we just got to work everything out. Easier said than done. Distribute. 36x minus 36. Other side FOIL. X squared minus x, boom, boom, minus x plus 1. Everybody see what happened there? And so then that's 36x minus 36. The other side, x squared minus x minus x. What's that? Minus 2x, right? Because 1x and 1x is 2x. Hey, look at that. X squared has shown up. X squared is on the scene. What do we do when x squared shows up? Get a 0. Right? See how it's just going to come out of nowhere. That's why I said it's going to wake you up in the middle of the night. X squared, get a 0. You just got to know it that well. It's going to show up all the time. So I'm going into the x squared game plan now. X squared with an equals, get a 0. So where am I going to get a 0? Left side or right side? Left, because the x squared's over on the right. Remember, you always make the opposite side from x squared become the 0. Don't you? So I'm going to, if you want, you can just jump these, Gary. I'll just subtract them. Subtract 36x and add 36. Subtract 36x and add 36. Is that good? Gone, gone, 0. Other side, minus 38x plus 37. Is that good? What do you do next? Factor, yeah, with the 2 parentheses. So x is in the front. What 2 numbers multiply to be, what times what's 37?
37, 1.
1 times 37. How do they add to be negative 38? Both negative, huh? If they're both negative, you lose $1 and lose $37, you lost 38. 2 negatives multiply to be positive. And then you set each one to 0, so you're going to get x minus 1 is 0, x minus 37, right? Because the 2 things times to be 0, either one could be 0. So you know the drill. Positive 1 and because when it jumps over, it changes signs, right? Positive 1, positive 37. Maybe. This problem began with a root, which means we need to check them both. Either one, both, neither could be imposters. This is our friend that lies to us. We got to be checking them. It's a sad relationship. All right, so yeah, they're both good, it turns out in this. Let's go, I'll do it with you though. Let's go check them. So 6 root of, what is it, x minus 1 plus 1? So I'm going to check x equals 1. And then over here, I'm going to check 37, right? Yeah. All right, we good? So let's check them. So put in the 1. Everywhere you've got x, put in 1. 6 root of 1 minus 1 plus 1 is 6. 6 root of 0 plus 1 is 6. That's 6 times 0, right? Which is 0 plus 1 is 6. Wait a minute. No, that doesn't work. I thought you guys told me it worked. What's that? Did I write it wrong? Oh, whoops.
It's still long.
And it's supposed to be an A. I'm just crazy. This craziness. There we go. Sorry. Really muffed that one up terribly. There we go. You got to write down the right equation. So then this should be, that was terrible. So this should be 1. So that's 6 root of 0. That's 6 times 0 plus 1. 0 plus 1. Yeah, that works, huh? So the 1 works now that I have the equation, right? Let's try the other one. Now let's try the 37 there. And there, does the 37 make it true? I've heard the answer is yes. Let's see. So that would be square root of 37 minus 1. That would be 36. Square root of 36. What's square root of 36? 6. 6 times 6 is 36. Yeah, 37 equals 37 makes it true. They're both good. So what do? You just type in both answers with a comma. 1 comma 37 is the answer. Both are good. Don't need parentheses or anything. Either order. Just put them both in with a comma on that. Is that making sense? So you must check. What do you must check? Any problem that begins with a root. Because the root can lie to you. So it will take that kind of effort. So square root of y, 4y plus 1. What's that?
That one took a long time.
Oh, did you do this one with somebody? Or just on your own?
On my own.
Just working through? Yeah, the double rooters are pretty terrible. All right, so remember the game plan for square roots. What we got to do first?
I don't think the trouble is the double rooters, it's that 6.
Yeah, you're right, of course. Yeah, because there's another double rooter that's just root each side. That's the easy one, huh? Yeah, you're right. So we got to get a root alone. Remember, the first step is getting the root alone. Remember when I wrote the steps for the root equals step 1, get root alone. Remember that? Before you do the parenthesis, by the way, here's the mistake I've seen a lot in the test. I'll see people go 2 power, 2 power, 2 power. Game over. It's all wrong. Everything's wrong from that point forward. Although it'll work out super nice. Watch how easy it is. Don't write this down. It's all crazy. Watch how easy it is. Minus y plus 4. Just right, because it just cancels it and cancels it. That's 36. 4y minus y is 3y. 24. This is beautiful. Subtract 24. 3y is 12. Divide by 3. Y is 4. That was so easy. Why did Mr. Heron leave all that white space on the test? I just needed through 2 lines. I got it. That's just garbage. From step 1, that's illogical. You know, that's the deal with logic. You must not step outside the bounds of truth. And that first step is false. Therefore, everything after that is false. Right? And so, that's not true. You can't, why not? Well, you can't just square right now. You have to first do what? Get root alone. Then do the 2 power. Now, I didn't ever tell you why. Here's why. Look, let me just show you a real simple case. 1 plus 2 equals 3. I mean, what's easier than that? That's true, right? Okay, what if I square, square, square? Is it still true? 1 plus 4 equals 9? Showing that it's just simply not true. To go square, square, square. You can only do 1 square on the left, 1 square on the right. So make sure you're following my steps. My steps aren't just willy-nilly. They're put in there according to the dictates of truth and logic. You got to do it exactly as I'm saying. Anything else is false. So you can't do 3 squares. You can only do 1 square on each side. That's all that's true. So, okay, so all that was a lot of what you don't do. What do you do then? Jump this root over. This root needs to be alone. Like that. Now 2 power, 2 power. Just once on each side. Here's the easy side. The root cancels the 2 power. And this is 4y plus 20. But the other side is going to be horrible. Well, it's a little dramatic. It's going to be a lot of work. Because of the fact that the other side, I've got to write 2 of them and FOIL that out. Why couldn't I just cancel out this root? Because of that plus sign. Remember how pluses and minuses make everything hard? Because of that 6 plus, you have to write 2 of them in FOIL. So when you do that, this 6 goes to both. I'm running out of time, so I'm going to probably not explain much. Boom, boom. 6 root of y minus 4. And finally, root of y minus 4, root of y minus 4. Plain y minus 4, right? Remember how we've talked that out? Like root 7, plain 7, right? 2 7s in, 1 7 out. So root y minus 4, root y minus 4, plain y minus 4. 2 y minus 4 is in, 1 y minus 4 out. Now what? This is ugly. Yep, it is. 4y plus 20. Let's group things up. 36, take away 4. 32. 6 root of y minus 4 and 6 more roots of y minus 4. 12 roots of y minus 4 plus the other y. Pretty bad, huh? It's a mess. What? It's like the problem's not really getting any better. It is. It just doesn't look like it. We're getting somewhere. Now, how are you even supposed to know what to do now? This should be driving you forward. What does it say? Whenever you've got a root on the scene, you have one mission. Get that root alone. And parenthesis 2 power both sides. So this root right here, this term right here is saying, get me alone. I'm a rooter. Get me alone. And then parenthesis 2 power both sides. That's always, yeah, but we already did that. Yeah, we got to do it again. Because this is a double rooter with another number, like Wendy was saying. Double rooter requires doing this twice. We got this root alone right here and 2 powered it. Now we got to do it again. Now we got to get this root alone. So how's that work? Get rid of the 32, get rid of the y. Get rid of the y, get rid of the 32 from both sides. So this will be what? 3y minus 12. Gonzo. 12 root of y minus 4. We good to there so far? We're almost there, I promise. I know we're going over. We're almost there. See what happened there? I'm going to leave the 12. Remember, it's okay to have a number multiplied by the root. I just don't want things added, subtracted. I'm going to leave that 12. So where are we at? Almost done. 3 minus 12 is 12 root of y minus 4. Now what do? 2 power, right? Get the root alone, 2 power both sides. What does that do? 3y minus 12, 3y minus 12. The other side, you square the 12, 144, because he gets rained on, he doesn't have an umbrella. And then you remove the root. So he goes there, he goes here and cancels the root. And then you got to FOIL. This problem is never ending. I thought we were almost done. Minus 36y plus 144. Boom, boom. Is 144y minus 4. 288, 4. I don't know. I'm tired of this problem. Minus 4 times 144. 576. And now what should we do? We got y squared. What do you do when you got y squared? Get a 0. Subtract 144, add 576. Subtract 144y, add 576. These numbers are terrible. So, and then we've got 9y squared minus 36y minus 36y Minus 72, isn't it 2 something? 216. Minus 216y plus, I don't know what that is. It's 720. These are terrible. You can factor a 9 out of everybody. All right, is anybody following me still? Sorry, this one's just terrible. These are on YouTube. I'm just running over time. Like I thought I could do it quick. This is if you factor 9 factors out of all these. I'll just do this real quick. Plus, I keep saying that, huh? 80. There it is. Factor it now. Y. 80. I don't know. 8 and 10. No, that won't work. What is it? 40?
20 and 4.
20 and 4? Oh, thank you. That's it. 20 and 4. Good thing Wendy's here. Equals 0. The 9 you can throw away, which sounds weird. The 9 doesn't have a letter. So the answers are just 20 and 4. The 9 doesn't have a Y. So he's a throwaway. I wish I had more time to explain that. Now you got to check 20 and 4. Are they both right? I don't know. 20, it'd be 80. 100 be 10. Minus 4. Yeah, 20s work, right? And what's the other one? 4? 0. Yeah, they're both right. They're both good. All right, guys and gals, we're over time. So there's more on YouTube. It's on YouTube. I did the rest of them in old